Guys, welcome back to the channel. So today's question is going to be count subarrays with fixed bounds, right? So the idea is kind of which is that you're given an array, and then you have a min k and a max k, and within this array, you're supposed to find the number of subarrays such that the minimum value in that subarray is min k, and the maximum value in that subarray is max k. So what I mean by this is, let's say if you look at this array 135275, you will know that 135 is a valid subarray because the min k is 1 and the max k is 5, and so is 1352. But notice that once you hit 7, no array which contains 7 is going to be a valid subarray, right? And in a similar way, when you look at the array with 4 ones, you know that min k is 1 and max k is equal to 1. So in this case, every possible subarray within nums is going to be valid. So essentially it's going to be 4 plus 3 plus 2 plus 1, 10. So all the possible 10 subarrays are all valid, right? So how do we solve the question? First thing to note is that, let's say you find a value that is lesser than minimum of k and greater than the maximum of k. You know that any subarray containing it is going to be invalid. So in this example, we have 7 here, right? So you notice that any subarray that contains the value 7 is going to be invalid. So what this means that any array starts from here, left index, right index, is going to be invalid, right? This is invalid, this is invalid, this is invalid, 7 onwards is all invalid. So what can we do about this, right? Notice that we know which indices will contain elements that are going to be invalid, because we can compute whether an element is lesser than min k or greater than max k, and then we take the indices of the subarrays that exclude this element. For example, in this case it will be 1352, so this rectangle here, and 5, right? And then for each subsegment we count the number of subarrays, right? So in 1352 there is going to be 2 subarrays, and if the subarray 5, there are going to be no subarrays because min k is not 1. And one quick thing to speed up the process, notice that, let's say if you go into each smaller subarray and you want to find how many subarrays are valid within this subarray, it's a typical sliding window kind of problem, right? You start at the left, you keep expanding until you find until this window is valid. This means that the minimum value is k and the maximum k is 5. So if I start from 1, I know that 1 is not a valid subarray because max k is not 5. You go on to the next index. 13 is not valid because it's not 5. When you go to 135, you know that this is a valid subarray because min k is 1 and max k is 5. Also, once you get to know this, understand that you can automatically derive that any subarray that starts from here ends here until the bigger smaller subarray is reached is going to be valid. So this means that 135 is valid and 1352 is going to be valid. So this will help you save a lot of time when you're kind of counting the number of subarrays in the middle. So essentially, once you reach 135, you get the index at which the biggest subarray ends, and you minus the current index of R. So that will give you how many valid subarrays are possible. Yeah, you need to add +1 depending on how you implement this, and my sliding window approach will require me to add 1 to it. And as with typical sliding window problems, whenever you find a valid subarray, you can increment the left pointer. Let's say it's 135, then I go to 35 and I see whether it's valid or not, right? If it's not valid, then there's really no much point to it. right? So yeah, so essentially that's how you kind of optimize and solve this problem in a rather quick time complexity. I'll go through the second example. So you have 1111. You notice that there's one at the start. Oh yeah, something I needed to say, which is that you need a hash map to maintain the count of values that occur within the subarray as you iterate through it, and then you need to add values and subtract counts as appropriate. This is because it's possible for there to be duplicate values, as you can see in the second example here. Right, so let's look at this example. Right, so you have this subarray 1. So you notice that when you add this index, you notice that both of the conditions are met. So you know that this, and this are all valid subarrays. So you add 4 to the score, and then you progress the left pointer one more, right? And then you find that this are all valid, and yeah, and then so there's gonna be 4, 3, 2, 1. If you add all of that up, it's going to be 10, right? And yeah, so that's pretty much how you solve this problem. Yeah, this is a pretty interesting problem, and yeah, it combines the two topics, which is usage of a queue and a sliding window. Yep, so that's how we solve this problem, and yeah, thanks for watching.